Okay, so in this example, this is what we're doing. We're taking a look at the graph here of a parabola, and we're determining the function that defines this parabola. And we're going to write the function in standard form. Okay, so we're going to start off by recognizing a few key points to this parabola. First of all, we know that it opens down. So guess what? We are going to anticipate that a is going to be negative, right? And of course, the standard form is y equals ax squared plus bx plus c, right? So we know that a is going to be negative. Okay, that's just we're looking ahead. What else do you notice about this parabola? Go ahead and shout it out. What are some important aspects of this parabola that we're going to need to write an equation? Anybody? What do we got? Roots. We got roots, okay? Or we've got x-intercepts. Good. What are they, John?
4 and negative 1.
4 and negative 1. Awesome. Okay. So we're going to say the roots are x equals 4 and negative 1. Okay, let's just jot that down. That's good. Okay, this is important. What else do we notice? I'm looking right around here. What is this right here? This is y-intercept. Okay, so let's just write that down. Y-intercept is 12. Okay. Now, these are just some observations, so we kind of have an idea already what our equation is going to look like. But this is how you do this, okay? One of the key points that we just mentioned was that you can write the equation for any parabola if you know the roots and one other point on the parabola. And I'm going to teach you how to do that. So what does that mean? Okay, well, the roots, we've learned that the roots correspond to binomial factors of the quadratic equation. So if we look at this, y equals a times x minus r times x minus s. Okay, so this was given in the key ideas above, right here. Okay, this one. That's what I'm talking about. Okay, so that's a pattern. Okay, that's a pattern for the quadratic, and that's in factored form. Good. So what we're going to do is we know that this value right here and this value right here are the x-intercepts. So let's go ahead and start with that. I don't know what a is yet, but x minus. Okay, what's our first intercept? Negative 1. So watch this. I'm going to put a negative 1 there. I know this is a little bit confusing, but I'm just going to show you how this works. If you remember x minus r, x minus s, then you just go ahead and put the intercepts in there, right? And 4 goes in here. So that's actually a times x plus 1 times x minus 4. Okay? And as we mentioned, if this x-intercept is minus 1, it should show up in factored form as an x plus 1. If the x-intercept is plus 4, it should show up in the factored form as x minus 4. So everything's working out just swimmingly here right now. All right. So we're not done. We're almost done, actually. Like, we're almost done this already. All we need is the intercepts. But we have to have some kind of indication on how tall this parabola is, how narrow its opening is, you know, that sort of thing. So we choose one other point to plug into this this format right here, one other point, an x, y point, so we can solve for a, because we need to know what a is. Now, there are many points that we know about here. Well, we know about the intercepts, okay? So I wonder if that would work if we chose negative 1, 0. If that would work, do you think it would work? It might work, although 0 is going to be y, and so we're going to have a equals 0 divided by something else. And is a going to be equal to 0? A can't be equal to 0 because, look at this, then it wouldn't be a quadratic. So we don't want to choose the intercepts, okay, as the points. Don't choose the intercepts. You have to choose another one. So if you know what the vertex is, you can use that. If you know what any other point is, this one looks pretty good. And of course, we know the intercept. So you can use the y-intercept. Okay? You could use the y-intercept. That's going to be great. The y-intercept is okay. The x-intercepts you can't use. So let's use the y-intercept and see what happens. So the point here is 0, 12, right? And I'm going to put 12 then in for y. And I'm going to leave a. I don't know what it is, but I know that x is 0. Okay? And so I put 0 in for each of these, right here. So what do I get? I get 12 equals, what's a times 1 times negative 4? That's negative 4a. Okay? and then a is going to be equal to 12 divided by negative 4, or negative 3. Okay? Now, just for curiosity's sake, what if I use this point, because I'm pretty sure I know this point as well. This one looks to be 312, the point 312. So let's just say someone else used that point. Okay? So I'm going to just rewrite this real quick here. And let's say we had 12 here, and we had a times 3 plus 1 times 3 minus 4. Okay. So what's that going to be? Well, 3 plus 1 is 4, right? 3 minus 4 is negative 1. So this becomes negative 4a. Look at that. Same as we had over here. So with any other point other than the x-intercepts, you're going to get the same value for a if you do your math correctly. And what that means is simply this. Now you can say that here is your equation, y equals, we're going to go back to this kind of step right here, and we're going to put our a in. So we have negative 3 times x plus 1 times x minus 4. So I've got the roots in there, I've got the a in there. The only final thing we need to do is to write it in standard form. And all that means is we need to just multiply everything through, okay, and gather like terms. So I'll do that just below here. So what's negative 3 times x plus 1? Negative 3x minus 3. Now I'm going to take that and multiply by x minus 4. So negative 3x squared and plus 12x. Again, I'm just doing FOIL. Negative 3x plus 12. So this is negative 3x squared. 12 minus 3 is plus 9x plus 12. So it appears that this is the standard form there for this question. So just go back and check some of my work here. Okay, that looks pretty good. So that should be your answer. And what you can do is graph this on your graphing calculator to see if it matches up with this problem. Right? You can totally do that. So, okay, so that's how you do that question. All you need is the roots and one other point, okay, to find the equation. I will show you one other thing from this point right here. Okay, so in the standard form, check this out. This constant, I think I've mentioned this before, but this is always the y-intercept. You guys remember me saying that? That constant is the y-intercept. So that's great. But another neat thing is this, is that the y-intercept is also, come on, let's change colors here a little bit. It's also c, okay, which is the, ax squared plus bx plus c, this is c right here, is also a times r times s. A times r times s. That is also the y-intercept. So if you're at this point, so look at this, negative 3 times 1 times negative 4 equals positive 12. Okay? So again, that's just something that you can just stick underneath your hat there and pull it out later if you want to double check an answer, or if you're like, I don't know if I got this constant right, or what's the y-intercept? They give me this form and they're asking me for the y-intercept. How do I do that? Do I have to multiply everything out? No, you don't. A times r times s. Done. Y-intercept. If you're given this form, what's the y-intercept? Oh, just the constant, whatever the constant is. What if the constant is 0? What if this was gone? What's the y-intercept then? 0. Yeah. Whatever the constant is, that's the y-intercept. Okay, so that's how you do that question. Any questions from you guys? Any parts of this that didn't make sense, or clarification? Okay. Okay, so take a couple minutes, and I want you to find the equation of this parabola right here using the same sort of method that I just showed you. So go ahead and take a few minutes to do that. All right, so the answer to the your turn question here. This one's a bit tricky because there's only one intercept. So what do we do with one intercept? Here's our form. Remember, here's our form. Shh, girls. The quadratic equation has to be x squared. It has to be a squared in there, right? So I don't know if some of you thought, well, we got one intercept, so that means I can stroke this one off and I can just focus on one binomial factor. In a sense, that will give you just an x term, not an x squared term. So you got to be careful. This is not a straight line, so we can't have just y equals something x. Okay, so that's the first part. It's like, okay, I can't just get rid of that. But in this case, what you need, because you need x squared, but because there's only one factor, one x-intercept to consider, then what you can treat this as is as two identical binomial factors. So the intercepts, technically, would be x equals a -1 and x equals a -1. So it'd be like they would be two identical intercepts. We need that because we need an x squared. So this actually turns out to be a times x plus 1 squared. Okay? So that's how you treat a single. Now that's a tricky one. I got it. That's a tricky one. I don't know if anybody tried that or not. But there's a few things you got to notice, and that's how you do this one. So we can pick a point that's on the graph. Any point looks like 0, -1 is on the graph. So if I do -1 here and I put a 0 here, then this becomes -1 equals, am I doing something wrong? What did I do?
-1 should be a -2.
Say what? Oh, this here. Oh, I see. Oh, yeah, this is down by 2. You're right. That's -2. So 0. So this one here, 0, -2, right here. Yeah. Thank you. Oh, this scale messed me up. That's right. It's 2. This one's 1. The y scale is 2. So then we have a equals -2 over 1, or a equals -2. Thank you for that. Everybody see that? Okay. So then our equation looks like this. Y equals -2 times x plus 1 all squared. And if you were writing that in standard form, you'd have to expand the x plus 1 squared. So that would be what? X squared plus 2x plus 1. And then multiply this 2 through. So it's -2x squared minus 4x minus 2. Okay? So that's the equation of that parabola. So yeah, so if you have one intercept, it's like having two identical intercepts. Okay? That's how you have to treat that with this, this setup. Okay?